We have seen that the BFS algorithm, and now we are going to extend the BFS algorithm to not only find a node but also construct a spanning tree. So what is a spanning tree? A spanning tree is a part of a subgraph of a given graph such that it is a tree and it covers all the nodes. So let's suppose if we want to find the path to every vertex from a source vertex to, and we can compute a rooted spanning tree using BFS. In our earlier version, we stopped at and when we encounter a specific node that we are looking for, instead of that we just keep exploring the entire graph until and the BFS stops on its own. In this traversal, we also keep track of levels, and we assign every node level whenever it is encountered. This is some additional information we collect, and later when we are about to prove some theorems about our algorithm, we need this auxiliary information. So here is the modified algorithm. When the green lines, line number 4 and line number 12 are added, where in line number 4 you can see that the starting node, root node, is assigned to 0, and there is no stopping criteria. Now we do not stop because we find some node. We only stop when the queue becomes empty. And line number 12, you can see that we have added level information. Whenever a node is discovered, the level of the discovered node is one more than the level of the parent node. Now let's look at run of our BFS and see how it assigns levels to various nodes. Entry is the starting point of our BFS, so we assign the level 0. Then we discover A. So since A is discovered by the node entry, so therefore the level of A will be 1. From A we discover F and B, their level will be 2. D and E are discovered because of B, so their level is 3, and level G and exit are assigned 4 accordingly. Now we will see how can we use this level information to prove that the BFS always finds the shortest path.